The rescue operation highlighted severe challenges due to unstable, steep earthen walls, which posed a constant collapse risk. Critical safety concerns included the dangerous proximity of personnel to heavy machinery, violating clearance protocols and risking accidental impact. Furthermore, emergency response stress often led to the abandonment of fundamental safety practices like PP usage and perimeter control. To optimize safety, units must mandate structural stability assessments, enforce strict exclusion zones, and ensure separation between ground crews and machinery. Temporary shoring must also be utilized to stabilize excavation sites. Strategic lessons emphasize the necessity of situational awareness training and standardized SOPs for coordination between operators and crews. Ultimately, effective rescue work must prioritize responder security. Standardizing these protocols in high-risk zones is essential to minimize future hazards. This incident serves as a critical case study on the dangers of working near compromised structural elements and the life-saving importance of situational awareness. In a renovation setting, an individual was working at the base of a tall, dilapidated brick wall that lacked structural integrity. A bystander, observing the wall's instability, issued a timely verbal warning, allowing the individual to vacate the area just seconds before the structure collapsed. This event highlights several fundamental safety breaches, primarily the failure to identify the danger zone and the absence of physical barriers or clear signage around unsound structures. Safety is a collective responsibility. Proactive observation and communication are primary factors in preventing catastrophic events. Moving forward, always assess structural stability before tasking, establish clear buffer zones, and maintain active situational awareness to identify environmental warning signs. When structural integrity is in doubt, prioritize immediate clearance over work tasks. Technical incident analysis reveals critical safety lessons. Truck tire inflation involves high-pressure risks. If a tire or rim is degraded or overinflated, stored energy becomes a projectile hazard. During the incident, the technician stood directly in front of the tire, the highest risk location. Standard protocols mandate standing aside, using extended reach hoses, and operating from behind protective barriers. Furthermore, the lack of an engineering control, specifically a specialized tire inflation cage, was a fundamental safety oversight. These cages are designed to contain components during a failure, providing essential protection. This event is a stark reminder to adhere to regulations when working with high-pressure equipment. Facilities must provide protective cages, train staff on positioning, and inspect tire integrity. Ultimately, workplace complacency can lead to severe health consequences, making safety the paramount priority. These incidents demonstrate that industrial operations involving high-pressure systems or heavy load handling require rigorous engineering safeguards. Often, failures stem from a miscalculation of physical forces or the violation of safety buffer zones. When operators position themselves within a device SS strike zone while relying on manual intervention rather than remote control tools, they face extreme risks if a system malfunctions. Furthermore, unstable working environments such as saturated terrain severely compromise an operator's footing and ability to escape during emergencies. To mitigate these hazards, organizations must enforce strict exclusion zones, apply the principle of energy separation to keep personnel at a safe distance, and conduct dynamic risk assessments before every task. Safety should never depend on human reaction time. It must be guaranteed through robust infrastructure design and absolute adherence to established protocols.